All right, so for the last two questions of the homework, so that's questions 11 and 12, you need to write the intervals of where functions are increasing, decreasing, or where they're constant. And now, one of the biggest issues here is how, and it might help that the questions are multiple choice, but um, is the how do you write an interval? So I just want to remind you that an interval, when we write intervals, they look a lot like if it's a point, right? So we might say something like this, and they go 3 comma 9, right? So context matters, right? So what do I mean by context? The word context, right? Um, so context is kind of what situation is this being used in, right? Is it are we talking about specific points on a graph, or are we talking, like I said, are we talking about intervals? So if it's an interval, well, if it's a point, right? We know what a point is. We know that a point, oops, a point, let's say 3 9 would be 3 and then 9. It would be one spot on the graph, one spot, right? Now, if I'm talking about an interval, then I'm going from the x value 3 in this. Let's assume that we're talking about the x values to 9, right? So I'm going from here to here. So I'm talking about an interval of on the x-axis, right? That's the difference between a point and an interval, right? So this is a point, and this is an interval. And again, the context matters. What's the situation that we're talking about? If we're talking about domain and range, then we're definitely talking about intervals, right? And if we're talking about here, where is it increasing, where is it decreasing? Again, we're talking about intervals. So just make sure that you understand the difference between this notation, when it's a point, when it's an interval, right? If we're talking about minimums and maximums, like where is a graph the lowest? Where is it the lowest? Well, that's going to be a point, not an interval, right? Where is it increasing and decreasing? That's an interval. So like right here, this is where it's decreasing. So that would be one interval. And here's where it's increasing. That would be another interval. Okay? So just make sure you know the context between the two. So now, what does it look like when we're doing this? So you'll more than likely you'll see a graph, right? You're gonna see a graph, and sometimes it'll be a not so nice graph. So if it was a parabola, let's say it's a parabola, right? And that this point here is I don't know, 5 comma 3. So we know that this is the lowest point, right? So that means on the left side, all this part right here, it's decreasing. It's coming down towards this low point, right? It's coming down. So we got to figure out what is that interval. So we already know that from parabolas or quadratic functions, the domain is from negative infinity all the way to positive infinity. So that means that we're coming in from, uh, uh, so where is it decreasing? We're coming in from negative infinity all the way to this number 5. Right now, I'm not going to include 5 in this domain or in this interval because at 5, that's where there's a switch between decreasing and increasing. So it's not doing either one. Um, and it's not constant either because it's just one spot, right? So then where is it increasing? Well, it's increasing at 5 after 5, right? So not, again, not including 5, but it's increasing from there all the way to positive infinity. Okay. So that's where it's increasing, decreasing. Is it constant anywhere? No. It does switch again here. The slope, and if you ever get into calculus here, the instant slope would be 0. So this is a negative slope, negative, 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 negative. It hits 0, then it becomes positive, and it switches over. So that's where it's decreasing and increasing. Now sometimes you'll see some other functions that are a little bit more, just kind of made up so that you can kind of practice this kind of stuff. So like they'll go like this, and then it'll go flat. Let's pretend that's flat, and then it'll go back up again, right? So or down. Let's change that. Let's say it goes down, right? So we can show that decreasing, and then it goes down from here this way, and then they'll tell you what this point is, -2 comma 3. This point's going to be, let's say, 4 comma 3, and then that's all the points you need. And let's just say this goes like this. If it goes forever this way, it goes forever that way. So where is it decreasing? So again, we're reading this going from left to right. So this is increasing, constant, and then decreasing. So it's decreasing over here on the right side, starting at 4, right? And on these transitions from one to the other, I can't really include that point. So it's going to be from 4 to infinity. Where is it increasing? Again, from left to right, I see it from here. It's increasing here. So it's coming in from negative infinity, because we said there's an arrow at the end. Or if they give you a point here, then you can say from here to here. So there to -2. And we're always, again, I'm only looking at the y values, right? I'm not even looking at I'm looking at the x values. I'm not looking at the y values. It doesn't really matter to me what the y values are, really, when I'm looking for these intervals. And then where is it constant? So it is constant from here to here. So from -2 to -4. I'm sorry, -2 to +4, not -4. To 4. That's where it is constant. Constant right there. Okay. So that's decreasing, increasing, and constant functions.